So today, hey, no talk. We're doing graphing quadratic functions in order to graph them in standard form. So that begs the question, what is standard form? Standard form is y equals ax squared plus bx plus c. Where a cannot equal 0, I'll say this in tomorrow's lesson as well, but if a were to equal 0 here, that would cancel out that whole first term. What would that be? If it's just bx plus c, what would the shape of the graph look like? Just a line, right? Because it's x to the first power, that makes a line. All right? The vertex is your next blank spot. Oh, I'm sorry. It's a parabola. I missed that one. So parabola is a U-shaped graph. Looks like that, right? If a is negative, if this a term is negative, then it just turns the graph upside down, reflecting over the x-axis, which you guys should know by now. Okay, the vertex represents a highest or lowest point on the graph. So here, the bottom is the lowest point. That's a vertex. You can also think about where the graph changes directions. So the graph decreases here and increases there. So where it switches directions, that's a vertex. If a is greater than 0, next one, the graph will open up. And the vertex is a minimum. So if you look at this one over here, is this a min or a max, the vertex? Min, because it's the lowest point on the graph. Right? If the graph's upside down, it looks like a mountain max. Easiest way to remember it. So if a is less than 0, the graph will open downward and the vertex is a maximum. The axis of symmetry is this line right here. It's the line that cuts the parabola in half. Okay? We get the equation of the axis of symmetry by doing x equals negative b over 2a. So we can identify a and b from the coefficients in front of x squared and x, and then plug it into x equals negative b over 2a. So that gives us the axis of symmetry as well as the x value of the vertex. And I'll say a lot of this tomorrow as well. Thank you. Okay. The formula to get the axis of symmetry is x equals negative b over 2a. The y-intercept is 0c. So whatever number is right here, that's also the y-intercept. So we'll do a problem tomorrow. We'll do one where there is a y-intercept you can see on the graph. Another problem we do, the y-intercept's like 143, and the graph doesn't go up that high, so we have to get some other order pairs to be able to graph it, which I'll talk about in tomorrow's lesson. So look at this graph right here. What's the vertex? What is it? What are the coordinates of that point? 2, 5. 2, 5. Is it a max or a min? I'm just going to circle it because it's right there. What is the equation of the axis of symmetry? There's the axis of symmetry. Normally we make it dotted. I'm going to make it dotted. Hold on. X equals what? Good. Right, so that's the axis of symmetry, meaning I can fold the right half of the graph over that axis of symmetry, and it'll exactly match up with the left side of the graph. So axis of symmetry is x equals negative 2, or positive 2, I mean. Come on. There we go. What's the y-intercept? 0, 3. What's the domain? If we write it in interval notation, just to remind you of all that stuff, from negative infinity to positive infinity, you could also, it just depends. If I ask for interval notation, you got to write it with negative and positive infinity. If I just say what it is, neither set builder or interval, you can just say all real numbers. What's the range? So yeah, if I write it like, where's it's, because we always go low to high when we're doing interval notation. So the low is negative infinity and the highest point on that graph is 5. Is it squared off or curved? Squared off. So if we don't specify interval or set builder notation, you could also write that as y is less than or equal to 5. So you might see either in the solutions. That's why I'm telling you both, because once you check your solutions, you might see something different. Okay, so we're going to do this next one. We got to come up with a graph. Right away, what's a y-intercept? 0, negative 3. So I'm going to make that dot on my graph, 0, negative 3. I've already got one of the points I need. You only need 3 points to be able to graph a parabola. One of those 3 points, however, has to be the vertex, because it's not always a vertex. Will this graph have a maximum or minimum? So I know that because A is positive. If A is positive, the graph looks like this. So it'd have a maximum or a minimum? Minimum. Good. Because A is positive, that's how we know. All right, so we're going to identify A, B, and C up here. So A is 1, B is 2, C is negative 3. We need all of those to be able to graph. We already dealt with the negative 3. I'm going to plug into the equation for the axis of symmetry and the x value of the vertex. So we plug into negative b over 2a. And do the math. So negative 2 divided by 2 is negative 1. Then what I'm going to do, I'll let you get caught up. So once I have that x value of the vertex, right? We have x equals at the beginning there. If it helps you to remember that it equals x, you can write equals x at the end too. Like you don't have to, but just remember it equals x. So I'm going to take that. If I plug it in here and here, I'm going to get all numbers and I can do the math, and then I end up with a y part of the vertex. So the little statement I always write for that, once I'm here, I say plug in x to find y. Plug in x to find y. So I'm going to do that. I'm going to do it up top because I'm kind of running out of room. So you have to use parentheses, otherwise you get a massively wrong answer. So I get 1 minus 2 minus 3. What's 1 minus 2 minus 3? Negative 4. You could take this right here and just plug it into your calculator too. Nothing wrong with that, right? Get the correct answer as long as you use parentheses, otherwise you get the wrong answer. So that makes my vertex what? Because this is what y equaled. So what's the x value of the vertex? Negative 1, negative 4. And we can make that point, negative 1, negative 4 is right here. I'm going to also draw on the axis of symmetry because that helps us get the remaining point that we need, the third point to be able to graph. So all I got to do is I look right here. This point is 1 away from the axis of symmetry. So all I have to do is move 1 away over here, and that's my other point on the parabola. just do the same distance from the axis of symmetry, and then we have enough points to make our graph. So domain, I'm just going to write it as all real numbers. And then the range, what's the smallest y value? Tori, what's the smallest y value? What? Count again. Did you feed him the wrong answer?
No, I counted wrong.
Greater than -4. Quit talking and you won't be so lost. Okay? So that's it. We're good. Right? If I wrote them both as interval notation, just to keep reminding you of that, I'd have from negative to positive infinity, and I'd have -4. We always go small to big for domain and range in interval notation to positive infinity. Remember, it's always curved at infinity. So we're going to look at this table below here, and we're going to try to figure out which one has the greatest maximum. It says it right here, greatest maximum. So we're comparing f of x, g of x, and the equation of h of x, as well as the description of j of x. So it really helps you to understand the parabolas. So what is the maximum of this first graph right here? 3 what? 3, 5. Is that maximum the vertex? Sure is. So, how can you tell what the vertex is on the next one? X values are going up by 1 each time. Fiona? The biggest number, right? So that's got to be the y part of the vertex. That's the x part of the vertex. So 2, 7. Which of those two has the greater maximum? First one, second one? Second one. Okay. How do we figure out the maximum of the next one? We got to identify A, B, C. That's correct. -1, B is -2, C is -5. Or +5, I mean. Okay. What should I do now? Jackson, what should I do?
Get the x equals negative b over
Negative b over 2a.
Yeah.
Pay attention, please. 2 over what? 2 times -1 is what, Jackson? -2. 2 divided by -2 is -1. Do I know the maximum yet? What do I have to do? Got to plug it in here and here to figure that out. So it's like a lot of work, this simple little problem, right? But doable. So don't forget the negative in front of x squared. So it's negative times the quantity -1 squared minus 2 times -1 plus 5. And that's what y equals. So we get -1 plus 2 plus 5. So 5 minus 1 is 6. So the vertex of that one is -1, 6. Which one has the biggest maximum so far?
2.
Middle one, yeah, 2. All right, so we have a quadratic function with a y-intercept of 0, -1, and a vertex at 1, 2. So if we think about that, let's just sketch a quick graph. 0, -1 right there, and 1, 2 right there. So is that right side up or upside down? Upside down, right? Because this would be the axis of symmetry going there. So this point would be over here. So it's got to go like that. Which one has the smallest maximum? That one, right? Because it's only 2. And the biggest maximum is this one here. So I forgot to write this up here. We're looking at the y value of the vertex. So which one has the biggest y value of the vertex? That would be an exceptional test question because you have to understand a whole lot to be able to solve that, but it's completely manageable. All right, we have one big problem left and then homework time. So you got to buckle up for this one. It's got a lot of stuff going on. So example 4 says a ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend. $120 per holiday weekend pass. This year, the resort is considering a price increase. They estimate for each $5 increase, they'll sell 20 fewer holiday weekend passes. So we need to know how much money should they charge in order to maximize revenue. So to maximize revenue, we're going to have an upside down parabola, and it'll be the vertex of the parabola. So if I say X, it's the number of what price increases? What are they going to increase the price by? $5 increases. Okay? So the revenue is $120. It's the amount of money generated. That's the revenue. Now we're going to write the equation. So if I have 120 plus 5x what's the other one come from? 680 minus 20 what?
20x.
X. Okay. Because there are 20 fewer holiday passes, right? So if we FOIL that, super fun. I like to use the box to FOIL because it makes it easier. So I'm going to write 120 plus 5x, 680 minus 20x. So this bottom one I can do quickly in my head. Minus 100x squared. Forgot the squared, almost. The upper one, if you multiply 680 times 120, you get 81,600. 680 times 5 is 3,400, and it's positive. 120 times 20 is times negative 20 is negative 2,400. The handy part about using the box is you can always combine these two diagonals. Right? You could write 5x plus 120 up top first and negative 20 plus 680 if you want. Doesn't really matter though. So my equation, my R of x, revenue of x, is negative 100 x squared. So 3,400 minus 2,400 is 1,000x. And then the C term is 81,600. So we're going to find the axis of symmetry. Shh. Row. Shut up. So we have A equals negative 100. B equals 1,000. C equals 81,600. So if I want to find the axis of symmetry, I use the x equals negative b over 2a. which is negative 1,000 over 2 times 100, 2 times negative 100. So the negatives are going to cancel, so it's 1,000 over 200. What's 1,000 divided by 200?
550.
Do you guys know this trick yet? If you have zeros on the end, you can cross them off. So what's it equal? 10 divided by 2. 1,000 divided by 200 isn't 50. It's 5. Okay? But that's a nice little trick because, like SAT, if you know how to do that, like SAT is all about time, right? So you got to do the problems quickly and accurately. And the beginning of SAT, you know how it works on the computer now, the SAT? Like if you get the first 10 right, your problems get really hard, and then you can finish sooner because you really know math. If you miss the first 10, then it'll keep giving you kind of easy-ish problems, but your overall score will be lower. So it's adaptive, the SAT, right? So it'll get hard enough that you can't do it for everyone pretty much. Just so you know, that's how it works. So this, we need to say that x value of the vertex is what they're looking for here. So we know 5 is the x value of the vertex. And that's dollars, right? Because we're talking about the revenue. So we interpret the results. A ski resort will make the most money with $5 price increases. They should charge. So how much should they charge for the pass? How do we figure that out? So we do 120 plus 5 times 5, which is 145 dollars. So I just plugged that into this part of the equation right here, right? To get that 145. Okay. We still got more. Hang in there. So we have to find the domain and range. So we're going to find the domain, right? That's where y is 0 when we find the domain. So I'm just going to write the 2 parenthesis ones because it's easier to solve if we do it that way. So you may or may not remember from Algebra 1, because it was a long time ago, we can use what's called the zero product property, and we take each of those parentheses, set equal to 0, and solve for x. And that'll help us figure out the domain. So when I solve that, I'd subtract 120 from both sides on the first problem. Second problem, I'd subtract 680 from both sides. Okay, so when I do that, I get 5x equals negative 120. Then I would divide that by 5. Negative 120 divided by 5 is negative 24. Does that make sense? Could x be negative 24? Can we have negative 24 $5 price increases? That doesn't make sense, right? So that is extraneous, which will happen a lot when we do these real world like problems. One of the x values work, the others won't. On this one, we have negative 20x equals negative 680. And then I just divide by negative 20, and that one's going to work. What's 680 divided by negative 20? 34. So that means our domain, so this is only finding the domain, right? So where's our domain start? If we think about a graph over here, so our graph would look something like this. At the top here, we would have 5. We know that x value. We don't know the y value of the vertex yet. We're going to find that out. So what do I have to do? Oh, let's talk about our domain though. This is 34. So our domain starts at 0 and it goes to 34. Okay. Now we need to figure out our range. So we have to figure out the y value of the vertex to figure out the highest point on that graph. So to figure out the y value of the vertex, we're going to plug 5 in to the original equation. So if we do r of 5, we have negative 100 times 5 squared plus 1,000 times 5 plus 81,600. When I plug all that in, you can just use your calculator to plug it in, right? We don't have to show all the steps of the math because those are big numbers, no need. We get 84,100. So that's our maximum revenue, 84,100. So what is our domain then? It goes from 0, which is the bottom down here, right, to 8,400 up there. So our range goes from 0, remember range has to be y, not x, to 84,100. So that's a whole lot of work on that single problem, right? We started it way up there. So it's kind of a pain, that thing, yeah? So homework is page 149. 1, 2, 3, 6, 7, 9, 11. Okay? 1, 2, 3, 6, 7, 9, 11. Right? Ready, set, go.